Input is more difficult than output. That's because there are more things that can go wrong. The user can type anything. You can have data overflow, wrong character types, old data can be left over in the buffer, and so on. I have 3 assembly language functions that prompt for data and then read it from the keyboard. The outString function from the previous lesson is used to display the prompt. All of the input functions use the getChar function, which returns one 8-bit character at a time. The getChar function is kind enough to handle the input buffering, timing, echoing the input characters to the screen, and what happens when the backspace key is pressed. Here in the BSS section, space is declared to hold the input. 1 byte is declared to hold an input character. An array of bytes is declared to hold a string. Now, the size of the array to hold that string is defined as the difference between the start address and the end address of the array minus 1 byte to make room for that 0 terminator. This is the first function. It prompts for and reads a single character from the input. Oh, by the way, notice the form of the labels inside the function. They start with a period. This makes them a local label. It's defined only in the space between the definition of regular labels. This means that it is a local label defined only inside this one function. This is also handy in defining macros. More about these advantages later. This function has one argument, the string used to prompt for the character. The character is initially set to the default blank, and getChar is called to read a character from the keyboard. The input character is tested for being the new line character, which means the user just hit the enter key. If so, a jump is made to the end of the function, and the default space character is used as the input. Otherwise, the first character that was input is used. This loop here flushes the input buffer by reading characters until the new line character is found. The new line character is the enter key. If the input buffer is not flushed, the next time this function is called, an old leftover character will be in the input. Then finally, at the finish, the stack is cleared and the character is copied into the AL register to be used as the return value. Then the function returns. The function that reads an input string works pretty much the same way, except it saves more than one character. The address of the input string location is stored in the EBX register. The first character is set to 0, so if there is no input, the result is the 0-length string. The maximum possible length is set in the ECX register. Now at the top of this loop, each character is tested for being the new line character, and if it is, the input is complete. If not, the character is moved into memory at the location of the EBX register, the pointer to the string. Then the pointer is moved to the next location in the string, and that location is set to the null byte 0 to terminate the string. Then 1 is subtracted from the counter, and if there is room for more, a jump is made to the top of the loop to get the next character. In the end, the return value is the address of the string in memory, and that's loaded into the EAX register as the function returns. Okay, there is one more input routine. This one inputs a 32-bit integer. First, a call is made to the previous function to input a string of characters. The next job is to read that input string and convert the ASCII digits into an internal binary number. Using the exclusive OR operation this way simply sets the registers to 0. ECX is going to be used as the accumulator as the digits are read, and EBX is to hold the input ASCII digit. The EAX register holds the address of the input string from the previous function call, and this instruction copies one character from it into the BL register, so now that character is in EBX. The ASCII digits are between the hex values of 30 and 39, and if this character is not one of those, we're through. If, however, it is an ASCII digit, hex 30 is subtracted from it, and the result is the numeric value of the digit. But before it can be added to the sum in the accumulator, the existing value must be multiplied by 10. That is done by first making a copy of the accumulated value, shifting one copy to the left by 1, and shifting the other copy to the left by 3. Shifting by 1 multiplies it by 2, shifting by 3 multiplies it by 8, and adding these two together, you get a multiplication of 10. The pointer is then moved to the next character in the string, and the loop starts over. The resulting value is saved in memory, the registers are restored, the resulting value is then stored in the EAX register, and the function returns. This function can, of course, be called from assembly language. This function calls each of them and displays the result. Here you can see how the prompt strings are pushed onto the stack and the return values are popped off the stack and returned. You can just as easily call the functions from C. Each function is called with a prompt passed to it as an argument, and the return value is displayed. Here's what happens when you run it. A prompt is made, and getChar waits for an input character. Whenever you make an entry, it's necessary to press the Enter key before any characters are reported to the program. Now, it is possible for you to write a program that will talk to the keyboard directly and process each character as it's entered, but there is not a portable way to do that. It depends on whether your C compiler has a function that will do it, or whether your operating system has an interrupt or a function that will do it. I did it this way so it would be as portable as possible.